Introduction. Magnetism. Magnets. The first known magnets was lodestone, an ore of iron which had the ability to exert a force on other pieces of lodestone and other material. These substances, which had the ability to be attracted to a magnet, were classified as magnetic materials. Iron, cobalt, and nickel, and alloys of these elements are strongly magnetic. These are referred to as the ferromagnetic materials. Examples of such alloys are steel, alcomax, ticonal, magnetar, stalloid, and mometal. Classifications of magnetic materials. A material which is easy to magnetize but loses its magnetism easily is said to be magnetically soft. Example, iron. A material which is difficult to magnetize but retains its magnetism is said to be magnetically hard. Example, steel. The table below gives a list of some magnetic materials. The name, composition, and properties and uses. The first one, name, alcomax / alnico / ticonal. Composition, iron alloys with various amounts of aluminium, nickel, cobalt, and copper. Properties, they are very powerful permanent magnets. Uses, electric motors, electric meters, loudspeakers. Next, magnetar. Composition, formed from powders of various metallic oxides by applying pressure and heat. The properties, they make very powerful permanent magnets. Uses, electric motors, electric meters, loudspeakers. Steel. Composition, iron and carbon. Properties, make very powerful permanent magnets. Uses, electric meters, electric motors, loudspeakers. Next, iron. Composition, the element iron. Properties, very powerful temporary magnets. Uses, electric bells, electromagnets, transformer cores, magnetic screening. Stalloid. Composition, 96% iron, 4% copper. We make properties, very powerful temporary magnets. Uses, electric bells, electromagnets, transformer cores, magnetic screening. Mometal. Composition, 73% nickel, 22% iron, 5% copper. The properties, very powerful temporary magnets. And uses, electric bells, electromagnets, transformer cores, and in magnetic screening. Magnetic force. Magnets exert mutual forces on one another and on magnetic materials. The force between two magnets may either be one of attraction or repulsion, depending on the orientation of the magnets, whereas that between magnet and magnetic material is always attraction. Magnetic poles. The 2 points near the ends of a magnet where the attracting force or power is greatest are known as the poles. A freely suspended bar magnet is observed to come to rest, always pointing roughly in the north-south direction, with each end pointed in the same direction. The end which points to the north is called the north-seeking pole or north pole, and the one pointing to the south is called the south-seeking pole or south pole. Fundamental law of magnetism: like poles repel, unlike poles attract. Magnetic induction: if a piece of unmagnetized ferromagnetic material is brought near to a bar magnet, it is attracted to the magnet. This effect occurs because of magnetic induction. The magnetic field of the magnet magnetizes the soft iron, so that the end of the bar closer to the magnet becomes a magnetic pole of opposite polarity to that of the closer of the 2 poles of the magnet. Because of the smaller distance of these 2 unlike poles, there is a resultant force of attraction. So magnetic induction always results in attraction. Magnetic fields: a magnetic field is defined as a region around a magnet in which a magnetic force may be exerted. The force acting in a magnetic field are vectors, that is, they have magnitude and direction. A magnetic field may be represented by magnetic lines of force or lines of force. A magnetic field line indicates the direction of the magnetic field acting on a north pole. Magnetic fields: note, the field line is a curve. The direction of the force at any point is the direction of the tangent to the curve at that point. You have a typical line of force. Direction of magnetic field: the direction of a magnetic field at a point is taken as the direction in which a north pole would tend to move if placed at that point.